Always, when starting to identify any type of tissue, we look at the apical surface or apical surface, however you want to pronounce it. The apical surface is also known as the exposed surface. So this is whatever is on the outside. And take a look. We always look at the apical or apical surface, and these cells are flat. So because they're flat, they're squamous. Squamous means flat. Now we have to give it the other name. Is it stratified squamous or simple squamous? Stratified means more than one layer. Simple means only one layer. So you have 1, 2, 3, 4. I'm not going to count them. There are more than one. So automatically, this is stratified squamous epithelial tissue. And this is found in your skin. The main function is to protect and isolate you. So now let's take a look at this other one. Where is it? Oh, they're placing it right next to another. All right, so I'm going to zoom in for you and take a look. Right off the bat, 9 out of 10 times, your anatomy professor will give you a slide of this, and you may ask yourself, or this is an analogy for you, that this looks like a donut. It looks like a donut because it has a hole in the center, and take a look, a hole outside. So 9 out of 10 times, your professor is going to give you cuboidal in a donut shape. It could be simple cuboidal or stratified cuboidal. If it's simple cuboidal, you have only one layers of boxy shaped cells. Take a look, and you know it's one layer because you can count the nuclei, and it's only one. And you also have this other structure that's called the lumen, which is the space in that donut hole, if you want to see it that way, and that's called the lumen. And right here you have another lumen, and then you have another lumen. Lumen. Right here, this layer right here, that's called the basement membrane, or the basal layer. Basement membrane, or the basal layer. For anatomy purposes, they're both interchangeable, otherwise specified by your instructor. Some professors are really picky about the differences. Honestly, it doesn't matter, they're interchangeable, so you can use both of them, but I would just ask your professor to confirm. Alright, so now, oh, by the way, a place in your body where this can be found is the kidneys, because you have kidney tubules, and the main function is to absorb, secrete, and excrete. So think about when you're going to pee, you're either absorbing the nutrients and you're getting rid of the waste that you don't want in your body, and you're excreting it as urine. Simple, straightforward, easy peasy. So now let's take a look at the stratified cuboidal. Again, remember I told you 9 out of 10 times your professor will give you one like this, and it looks like a donut. A hole in the center, a hole outside. Now, what do we call this again? I hope you said lumen. Now I kind of look like Dora right now. But yeah, that's the lumen. By the way, this is the apical surface. All of these cells are exposed to this lumen. I hope that made sense. And this right here, that's called the, I hope you can answer this, it goes by two names, basement membrane or the basal layer, however you want to pronounce it. And we know that this is stratified cuboidal because 1, the donut, 2, they're boxy shape, and 3, you can count the nuclei in the first row, and under that first row you have another set of nuclei right there. So right off the bat, stratified cuboidal. A place in your body where this can be found, they're really rare in the kidney tubules, but they're more common in the sweat glands, salivary glands, etc. Again, their main function is to secrete, excrete, and absorb, just like this little guy right here. So simple, stratified. I hope you got it. So now let's move on to the simple columnar. By the way, I kind of have to go fast because otherwise this video is going to be like a 40-minute video, and I don't want that. So let's take a look at this guy right here. These cells are shaped in columns. Hence, they're called columnar epithelial. So they're much elongated, meaning that they're long. Take a look at that compared to this. This is a short guy, and this is a long guy. So, or girl, it's 2019. So take a look. They're elongated, they're one after the other, and they're continuous, meaning that you have one cell adjacent to another one, adjacent to another one. Adjacent just means right next to, by the way. So all of these cells are right next to another, and again, this is one layer, so it's simple. Now you may ask, what's this? Don't worry about that. That's another type of tissue. You're not responsible to identify that yet. So this right here, that's the basement membrane or the basal layer, however you want to pronounce it. And these right here, that's the nuclei. A place in your body where this can be found, that's the intestines. So if I move over to stratified columnar, let's take a look. Again, you got those elongated cells that are right next to another. But in this case, you have two sets of rows. You have the bottom row and then you have the top row. Now these are very rare, but again, they're found in the intestines, so that's another one. Let's move on to one of the most important ones. I'm pretty sure your professor will ask you to identify this, and this is the transitional. Now you may be asking yourself, how the frig am I supposed to know this? Like, where am I supposed to even look at? But remember that I told you, always identify at the apical or apical surface. And if I zoom in a lot for you, you'll be able to appreciate that these cells have domy shape or muffin shape structures. And that's the giveaway. As soon as you see a dome shape cell, you should be automatically saying that's transitional epithelium tissue. Transitional epithelium tissues mostly found, I would say, urinary bladder, and its main function is to allow for it to expand, meaning that it can carry large volumes. If you think about it, your urinary bladder, sorry, this is why I'm not an art major, your urinary bladder might look that way, and when it's empty, it's really relaxed. But when it's full, meaning that it has a large urine, it expands. So that expansion allows for high volumes to push on the walls. And when those volumes push on the walls, those muffin-shaped little cells are no longer muffin-shaped, but they flatten out. So for your test, your professor will not give you a histology slide of a cell that's flattened out for you to say transitional. The professor must be able to give you a domy shape like these ones. I'm going to delete these so that you can be able to see it. There you go. So now, moving on. Pseudo-stratified ciliated columnar epithelial. Yes, that was a Harry Potter spell right there. So, dear Lord, what are we looking at here? The prefix pseudo, by the way, means false. Just like my ex. So the pseudo-stratified ciliated epithelial tissue is mainly found at the trachea. And take a look. The prefix pseudo, I said, means false because it's tricking you into thinking that it's stratified. That's why it's called pseudo-stratified. It's tricking you into think that there's more than one layers, but in reality, they're just scattered around all over the place. Take a look. They don't even have, you're trying to outline one row, but then you have another one that comes back down and comes back up, and it's just too messy. That's why it's called pseudo-stratified ciliated. The part ciliated, if I zoom in for you, take a look. That's cilia. Now, you might want to know this because that's 100% going to be on your test. I can bet you $100. The main difference between cilia versus microvilli. Microvilli is more short, it's shorter and more abundant, meaning that there's more of it. And cilia is longer and less abundant, meaning that there's not as many. And if we take a look, that cilia looks like hair. And the main function of the cilia is to move things across the surface. Let's pretend that this little guy is, I don't know, just some dust particle right there. So the cilia are going to move like waves. And they're going to move this little guy out so you can sneeze it or cough it out of your system. The way that this function is that these little guys, the white cells, ding ding ding, very important for you to remember, these are called goblet cells, and they look like big globs. Take a look. By the way, these are the nuclei, and the nuclei most of the times are going to pick up the dye as purple. So these guys are not as purple as you can see. They're more transparent. They're more like transparent structures. But these are called goblet cells. The main function of a goblet cell is to secrete mucus. Now, you want that mucus to be secreted out so you can trap this little guy, and then the cilia is going to move it. I hope that made sense. So again, they're found at the trachea. So let's go on to my favorite and least favorite. I have a love and hate relationship with this one. I love it because it's so easy to identify, and I hate it because you just gain weight like crazy. And this is called the adipose tissue. Now the adipose tissue is so unique. A lot of people get it confused with the simple squamous. Remember that the simple squamous, and I'm moving right here, the simple squamous was the first one. And I said that the simple squamous was the eggs on a pan where you had the nuclei in the center. But take a look. This cell is so fat that the fat droplet actually pushed the nuclei off to the side. So all of these little guys, that's the nuclei of a fat droplet. So the nuclei has been pushed to the side because it's so fat. So the nuclei is not centered. So that's the giveaway. The adipose tissue, the main purpose is to cushion, protect, and it also acts like an alternate storage of energy. It can be found at the breast or the buttocks, the abdominal area. I mean, those are just some places you can mention for your test. So, moving on to areolar connective tissue. So, areolar tissue, we usually say that it's an open framework. Open framework. Now, what that means is that open framework means that you have spaces that are very, very open. You can see that that's open. And if I compare that to here, you don't see spaces that are open. But here, take a look. All open, 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 open. So it's an open framework. Now, areolar connective tissue is really important because 9 out of 10 times, again, your professor will ask you to identify these strings that you see here. So those strings are called, they're fibers. You have 3 type of fibers. And the mnemonic I always give is SIR. The first one is the collagen fiber, elastic fiber, and reticular fiber. And it goes in order. It's large, medium, and small. So let's take a look. If I go ahead and outline this little guy for you, that's a collagen fiber right there. Now, if I take a look and just ask you what this is, well, that's the medium. That would be the elastic fiber. But I hope you can see. I'm gonna zoom in, and do you see this right here? Do you see how thin that is? That's the reticular fiber. It looks like strings of hair. They're barely there. They're really, really thin, but they are there. So again, areolar, open framework, 3 type of fibers, the SIR, collagen, elastic, reticular, large, medium, small. Simple. Now, moving on. Reticular tissue, right here. Reticular tissue has reticular fibers. I'm going to use red right here. All of these right here, those are called the reticular fibers. Right there. All of those. The main organ that has these is the liver. So you might want to remember that organ. Usually an analogy that I give, I hope it kind of makes sense to you, is that it looks purplish, and if you ever had liver before, the liver kind of looks brown purplish, so you can make connections. It's just up to you. All right, so moving on to your 3 types of cartilage. The first type that you see right here, oh my god, that is really, really small. That's a joke. I'm gonna that's an overplayed joke in 2019 at this point, but I'm enlarging this for y'all so that you can appreciate. Now, hyaline cartilage is known for its glassy or smoky appearance, meaning that it's very, very clear. Again, 9 out of 10 times, don't quote me, it's gonna look purple. It's very clean. Even though there is fibers in here, you don't see it because the dye doesn't pick it up. So hyaline, cartilage, glassy, smoky, hazy, really straightforward. Yeah. So hyaline cartilage is found many places, but one of them is at the tip of your nose, or even at the ribs. So if you ever heard of someone getting a nose job at rhinoplasty, and they need to get cartilage to fix their nose, they usually head for the ribs. Hashtag Michael Jackson. Moving on to elastic cartilage, we have elastic fibers. All of these, take a look. All of those are elastic fibers. They're really abundant. Let's compare. I mean, honestly, the comparison, I can do a million of them, but the main one is that this one, even though it has fibers, the dye does not pick it up. This one, on the contrast, it does. This is called the elastic cartilage. Now, the elastic cartilage is found at the ear. Easy, E with E. Ear, elastic. Straightforward. By the way, I skipped this, I shouldn't have. This little guy, we call that, the cell is the chondrocyte. The prefix chondr refers to cartilage, and side, cell. So it's a cell cartilage, or a cartilage cell if you want to think about it. But that's just the nuclei right here. Now, the space right there, it's called lacuna. You add an E for plural. Don't even stress too much about it. So if your professor asks for the space, you say lacuna, because Oscar taught me. And if she or he wants the cell, you say chondrocyte. Easy peasy lemon squeezy. Moving on. So we said that this is hyaline cartilage, elastic cartilage, and we have the last type of cartilage, which is my favorite one, which is the fibrocartilage. Now, the fibrocartilage is really important because it's the strongest of the three, and it's really simple to identify because, take a look, they are making rows, and that's the giveaway. The rows that they're making, one after the other, you have one and then you have another one, another one, another one, another one, though that's the giveaway. So they're right next to another. All of those are individual cells, meaning that that's one cell, another one, and another one, and they're making rows. If you compare that to that, Jesus, I'm not even gonna know, but if you compare that to that, still they're both scattered. So fibrocartilage is the strongest cartilage, and they're making rows. They're found at the knee joints. Knee joint. I can't spell knee right now. And we call that meniscus. I don't know how to spell knee, but I can spell meniscus. Or also in the intervertebral discs. Discs. Now, if I were to draw your vertebrae, this is one vertebrae, this is another vertebrae. In between, you got a disc. The word inter means in between. Vertebrae refers to your vertebra right here. So you got a disc that's in between your vertebrae right there. If you ever heard of a herniated disc, oh my God, Lord have mercy on those people, because that is such a big pain. Your back hurts all the time. All right, so let's move on to dense irregular connective tissue. Where did that little guy go? Right here. Dense irregular connective tissue. Oh my God, this looks like a beef, like a steak, a raw steak of meat. All of these are collagen fibers. So if you take a look, they're not arranged in a way that they're right next to each other. In reality, they're all over the place. Actually, this is a 3-dimensional shape. If you can imagine this collagen fiber coming this way, and then maybe this one coming that way, and then maybe this one coming towards outside the screen, and then just someone getting a knife and split, like cutting it, that's why it's all over the place. Now, this type of tissue, by the way, is deep to the skin. So if you go ahead and pinch yourself and just twist that pinch around, that's going to allow your skin to move in all directions. Hence, that's the dense, irregular connective tissue working. It allows you to move in all directions, all over the place, because the bundles are arranged in all over the place. So it's deep to the skin, and you can move it in multi directions. You can distort it, and then it'll go back to its original shape. So now let's compare that to the dense regular connective tissue. The dense regular connective tissue, take a look. All of those collagen fibers are arranged parallel, meaning that they're right next to each other. So you have one and another one and another one. This is really, really strong. Two places in your body where you have this are your, they're your ligaments and your tendons. So your tendons, that's an S. Your tendons and ligaments are made up of dense, regular connective tissue. It must be regular because it's really, really strong when they're arranged right next to another. Versus this is irregular, all over the place. Let's see, elastic tissue. Think of this as a rubber band. And why I say rubber band is because all of these squiggly lines, all of those are elastic fibers right there. A place in the body where this can be found are major blood vessels like the aorta, which is the biggest blood vessel in your body. You'll see that in another unit, because it has the ability to expand and contract, and that has a specific term which we call vasodilation or vasoconstriction, meaning that it can dilate really, really big, or it can constrict really, really small. And by doing so, these little fibers are going to allow it to expand or to recoil. So I hope that kind of made sense. So if you think about like a scrunchie or a rubber band, you pulling on it and letting it go, I hope that kind of helps you remember. Now let's take a look at the blood. Where's the blood? The blood is right here. Now these little guys, they go by two names: red blood cells. Now people who call it RBCs are the people who don't study anatomy, but us anatomists, we call it erythrocytes. The prefix erythro means red, cyte means cell, so it's a red cell. Now if you want to go bougie, call it erythrocyte. RBC, it's kind of whack. You're studying anatomy, so you should call it erythrocyte. Now this little guy, we call that a white blood cell, but again, we call it a leukocyte. The prefix leuko means white, cyte means cell, so it's a white cell. Now if I zoom in for you, I hope you can see these little guys that are barely scattered around, and those are called platelets. Now the platelets they're fragments, and it depends on your professor, but platelets are fragments from this big cell that's called megakaryocyte. I don't know if you need to know this, but if you do, it wouldn't hurt you. It's called megakaryocyte, and the megakaryocyte, it's a big cell, and it breaks into little pieces that we call platelets. And the platelets, the main function of it is to cause something to coagulate or create a clot. So when you cut yourself, the platelets get all together and then they create a clot. Of course, there's a much process in detail that you're probably going to see later on. So now let's move on to bone. Bone is really, really fun for me because it kind of looks like a tree trunk. And take a look. So this whole thing, this whole bracket, I'm going to switch color to red. This whole bracket right here, we call that the osteon right there. Right in the central, we have the central canal. And these right here, these are the osteocytes in lacuna, E for plural. So again, these are the osteocytes in the lacuna. The prefix osteo refers to bone, cyte, cells. So they're bone cells right there. Other than that, I mean, where can it be found? It's the bone, obviously. Moving on to the nervous tissue. The nervous tissue, really straightforward. I mean, who doesn't know a neuron? It's probably because you live under a rock. So you have this space right here, which is called the soma. Soma means body, so it's the cell body. This is called the soma. And then you have these little projections right here, which are called dendrites. And then you have the largest aspect of the neuron, which is called its axon. So the nervous tissue is found at the brain or the spinal cord. And then you have supporting cells that they're called neuroglia. I don't know how much you need to know about in detail, but supporting cells are just neuroglia. They're actually more abundant than neurons, but they're just there to support mainly. Versus a neuron does an electrical impulse, meaning that it passes information, while the neuroglia do not. Moving on to the skeletal muscles. By the way, you have 3 types of muscles. Go ahead and pause the video and tell me, or write on a piece of paper, the 3 types. I'll write them right now. So the first type is skeletal muscle. The second one is smooth muscle. And the third type is cardiac muscle. Voluntary, involuntary, involuntary. What does voluntary mean? Voluntary means that you have control over it. If you tell your arm to go up, you'll raise your arm. Involuntary means that you do not have control over it, meaning that if you tell your heart, cardiac refers to heart, do you tell your heart to beat? No. Do you tell your heart to stop? You don't. Do you tell your stomach to shrine the food? No. Do you tell your intestines to move the food along? No. So that means involuntary. You do not have control over it. You only have control over the skeletal muscle. Now, this is the skeletal muscle. I'm sorry, going back again. Out of these 3, only 2 are striated, skeletal and cardiac. Striation just means that the color bands you can see right here, that's dark, and then that's light, and then that's dark, and then that's light, and dark again. Now, I don't want to get into details because you're going to see this in the future, but these dark and light bands, they're actually made from 2 types of proteins, which they overlap, and that's why they make those stains. But right now you don't need to know those details. I hope not, and if you do, I don't know why you're taking anatomy with that professor, because this is already too much detail. But moving on, this right here, that's a whole cell, and it has more than one nuclei. So skeletal cells are multi-nucleated. The prefix multi means more than one, more than 2. So it has more than 1, 2, 3, 4 nuclei per cell. So 1, 2, 3, 4, 5 nuclei in one cell. Where's it found? In your muscles. It's voluntary, meaning that you have control over it. Let's see. Right here. Now moving on to the second type of... why can I grab this? The second type of muscle, and this is called the smooth muscle. And the smooth muscle is kind of like a cylinder shape. Some people say like cigar shape. I hate anything that has to do with smoking, so I don't like to give that analogy. So no smoking for anybody. It's really bad for your health. So these are cylinder shape right there. Cylinder shape cells, one after the other. They're non-striated. I don't know why I wrote that, but that means that they do not have striations. Question: is this voluntary or involuntary? 3, 2, 1. Involuntary. I hope you said involuntary, and I kind of look like Dora, but I swear that this is the best method to study. Where in the body can this be found? Hollow organs. A hollow organ is anything like your stomach, esophagus, small intestine, large intestine. So you can give any of those organs in your test. Moving on to cardiac muscle. This is my favorite slide of all time. It's really, really cool. And I'm going to zoom in. The cardiac muscle is known for its pans or gene shape little cell. So if I go ahead and draw this for you, they're branched. And when one cell meets the other, it creates this zone of overlap right here. And we called it the intercalated disc. Inter means in between. Well, I don't have to break this word for you. Just remember intercalated disc. They're branched. They look like a pair of jeans or a pair of pants. And then when one cell comes in contact with the other, they create those intercalated discs. All right. So again, is a cardiac muscle voluntary or involuntary? 1, 2, 3, go. It's involuntary, meaning that you do not have control over it. You do not tell your heart to beat or when to stop. If that was the case, you'd probably die because as soon as you go to sleep, then, how are you going to tell your heart to beat? So just think about it. Involuntary. And again, it has striations, meaning that there's dark and light colors right next to each other. So let's move on to the epidermis. Now, this is the skin. Oh, God. This is honestly, I'm going to be real honest with y'all. Skin is my least favorite. I don't know why. It's just so tedious. But I got you. I'm going to give you a mnemonic for you to remember on the layers of the skin. And that the mnemonic goes as follows. Come, let's get sunburn. And this mnemonic starts from the top going down. Okay? C, corneum. L, lucidum. G, granulosum. S, spinosum. B, basale. Easy peasy lemon squeezy. Come, let's get sunburn. It's gonna start at the top and end at the bottom. So all of those have stratum. So again, stratum corneum. I probably just did a Harry Potter spell, but it's okay. Stratum granulosum, stratum lucidum. But that's the only way, honestly, by laughing is the only way for you to remember anatomy. So, come, let's get sunburn. That's the order. Now, stratum corneum, this layer is dead skin. This is gonna shed, honestly. But take a look. This is thick, like me. Just kidding. This is thick skin. So the main question that I always get as a tutor, what's the difference between thin versus thick skin? And I'm here to tell you that it's this little guy. Stratum lucidum is only present in thick skin. It is not present in thin skin. Now, if you speak Spanish or Armenian, because I have Armenian friends, they told me that luz means light. So like, bare luz, I hope I'm saying this correctly, because they don't speak Armenian, I only speak Spanish and English. But bare luz, according to them, is good morning. So luz refers to the light. If you speak Spanish, luz means light. So this layer right here, that's a lightish color right here. It transitions, so it goes from purple to light purple to dark purple. So again, stratum lucidum is a light color. Anything else other than the stratum basale and lucidum? That's the only important ones. Lucidum is present at thick only, not in thin. And the stratum basale contains some specialized cells that are called melanocytes. And the melanocytes are responsible to produce melanin, not melatonin. And why am I telling you this? Because your professors will try to trick you, giving you both answers. Melatonin is for you to, some people take pills. I'm so against it. But if you want to do you do you. But melatonin is for sleeping. versus melanin is the pigment of your eyes and your hair and your skin. So melanin is the pigment, melatonin is for sleeping. Usually people take melatonin when they're jet lagged. Hopefully you don't take it because then your body stops producing it. This is why I don't like people taking it. So now let's move on to the dermis. By the way, let's get sunburn. All of these layers belong to the epidermis. The prefix epi means above, dermis. So you're above the dermis. Right now, I'm going to concentrate on the dermis. So that's the dermis. Epi means above. So that's the epidermis. And the epidermis contain the let's get sunburn. Alright, so the dermis has 2 layers. The main layer, which you see right here, we call that the papillary layer. And it also contains the second layer, which is called the reticular layer. Now, why is it called papillary layer? A papilla means a projection. So these projections right here, that's called a papillary layer because they project outward. And then you have the reticular layer right here. I hope you can answer this question, because if you do, I'm going to be really, really happy, but I'm going to zoom in for you. If you were responsible to tell me what type of tissue this looks like, please, just try to answer this question. If your professor gives you this histology slide and asks you, identify the tissue, what would you say? 1, 2, 3, go. The answer is dense, irregular connective tissue. This looks like a piece of beef, a steak. Remember that I told you? So the reticular layer is dense, irregular connective tissue, while the papillary layer is the areolar connective tissue. Those are the main differences. Good? Alright, so now let's take a look at this little guy, and we call that you have a hair follicle and all this other structures. This right here, that's a hair follicle. Now, I want to emphasize on this little guy, and we call that the erector pili muscle. The erector pili muscle is really, really funny because I don't know if it's ever happened to you, but when I listen to Ariana Grande, because I really enjoy listening to her. Her music just makes my hair go up. I don't know if that ever happens to you. When you listen to a good song of your favorite artist and you can connect to the lyrics, your hair will stand up. Or even if you get the chills, you get me? Now, that's the erector pili muscle. This is smooth muscle, meaning that you do not have control over it. That's why if you tell your little hairs to go up, they will not. Something has to stimulate them. Now, if I zoom in for you on this little gland, we call that the sebaceous gland. Sebaceous gland. The sebaceous gland is responsible to secrete sebum, and the sebum is the oil. So don't say no, because people who say no, they're liars. If you have not showered for at least one day, you'll notice that your hair will go oily. Now, don't tell me that's a lie because Oscar, don't say that because I've always showered. That's a liar. Don't say that because when you go to road trips or when you go to camping, you never have a shower available for you at times. So stop lying. So sebaceous gland secretes the oil which are going to lubricate your hair. That's why it looks oily. Now you also have this other gland that's called the sudoriferous gland, and the sudoriferous gland, you have one right here. You have one right here. The sudoriferous gland is responsible to secrete sweat. If you speak Spanish, sudoriferous sounds like sudor. Sudoriferous, sudor, which is sweat. Remember that all of the medical terminology is derived from Latin, and so is Spanish. So this is why a lot of words in Latin, we can connect them in Spanish, and it's just much easier for us to understand. So that's that. Moving on, right here you have the dermal papilla, and then you have the little bulb. And this is a hair follicle, by the way. You have the shaft. I don't know what your professor wants you to know of this. Honestly, it's very, very rare that they ask you. If anything, they're probably going to ask you for the dermal papilla or the bulb or maybe the shaft, because that's what they're interesting. Their interest. So I want you to show you this one last slide, and this is the skin. Ooh, and I just want you to know the difference. That's the epidermis. I hope that you remember that epi means above, and then you have the dermis, and then you have the hypodermis. Hypo means below or under. Epi means above. So hypodermis is under the dermis. Why is the hypodermis important? Because all of this, that's adipose tissue. All of this, all of that, that's adipose tissue. So if your professor asks you what type of tissue is found at the hypodermis, you say Oscar told me is adipose tissue. Good. And that's it. That's it for histology. I hope that this helped you a lot. I know I am not the best at doing this really, really fast, but I just want to get it over with so you can just understand the material. I went over it really, really fast, but again, I don't want this to be a 2-hour video. I gave you the essentials. Please don't forget to study, and also don't forget to like and subscribe, and please, please, please leave a comment down below telling me your test score. Even if you got a 1, I love reading your replies, and I always get back to you. So thank you so much for watching this video. God bless, and please keep calm. If you set your mind to it, you will accomplish anything that you put your mind to it. So I'm just gonna pray for all the students that are going to have a histology exam, and God bless you all, and I hope you pass this exam, because if anything, this is gonna be the exam number 1, which is going to be the easiest of all anatomy. So being that said, have a nice evening, morning, or night. Don't forget to eat something before your test. Do not pull an all-nighter, and yeah, don't forget to share. And again, God bless you.